Hi, my name is Tomas Sanchez. I'm a master's student at University of Oklahoma, and I am presenting my final project for Computer Vision 2025. I work for Macro Manufacturing. Macro Manufacturing designs, develops, and manufactures machinery for fusing pipe. Part of those machines are heaters, as you can see in here. These heaters are used for heating plastic pipe and fusing them together. There are some methods that are established for testing these heaters, especially and particularly the performance, but sometimes issues might arise where the temperature distribution across the heater surface is not uniform. This can lead to cold spots that may indicate potential defects. So the idea behind this project is to be able to use a thermal camera and computer vision techniques so we can determine average temperature of the surface of the heater, and we can detect cold spots or some spots that might be particularly telling us that there might be a potential problem with the heater. This project is an embedded system project as well, meaning that this tool should be able to be carried around or be in different spots. For that reason, a microcontroller was used. In this case, we have used the Raspberry Pi 5 with a 16 gigabytes RAM capabilities. And finally, a touchscreen display has been selected that works with HDMI with the Raspberry Pi 5. And here you can see the app. Here you have the whole system, the display, MCU, camera, and heater. The camera used is a Waveshare camera with capabilities of 25 FPS and 45 degrees of field of view. So this is the application itself. So this application allows us to have an image of the heater live. This is a live video of the heater. We're able to see minimum temperature, maximum temperature, average temperature of the heater, as well as delta, giving you the difference between the max and the min at recorded temperatures. So here we have the application. As you can see, we have a live streaming video of the thermal image. We get multiple information within the image. We have minimum temperature, which is shown with the light blue marker. The max temperature is shown with a yellow marker. So these are actually locations within the surface. So we are able to point directly to the user where the max and minimum temperatures are shown on the surface of the heater. As you can see, the whole thermal image is being masked out. So only the actual heater surface is shown. Then we have timers. The first timer, which is labeled as a target temperature, it's pretty much the timer to help you figure it out how long the heater takes to get stability on its surface temperature. Another important aspect of the application is that we are able to detect the edges of the heater um, so that we are able to mask out any area that doesn't belong to the actual heater surface temperature. Another aspect of this application is that we have the ability to have boundaries within the heater surface. So you can see here the the green circle shows the outer circle boundary, then the red one shows the inner circle. And the importance here is that we only care about the temperature measurements within that area. So as you can notice, both markers for minimum and max temperature, they don't go outside those particular areas. You're able to modify the diameters of the boundaries, and in this case, this is really important because even though the thermal camera might give you really good readings, sometimes really near the boundary of the object, in particular with this heater that is constantly changing temperatures, you might get false readings really near the edges. So that's the reason for creating this, and then you can recalculate, as you can see, the contour. And the idea here is we use canny edge detection and contour detection. We draw pretty much the edges
and the contour, and sometimes we might not get a complete contour drawing. So what we do is we use morphology techniques to complete circles. Something that is also important here is that we're able to hide the boundaries, so you don't have to have the markers within the live streaming video. Then we are also able to do thermal stabilization points where you can enter the target temperature. As you can see here, we're able to enter the 450-degree target temperature, and here we have the ability to choose between 4, 8 to 12 points of stability readings that we want to have. And here I selected 4, and we get the whole live readings as along with the delta temperature, which is pretty much the max and min. And here I could select, for example, 12 points, and we as well get all the live readings of each one of the temperatures within the surface. Something important is that these points are drawn within the boundary area that we selected. So within or inside the inner and the outer circle boundaries that we draw, which is really important because this makes sure that you are reading temperatures within your live streaming that where you as the user can be comfortable recording, because it gives you the ability to make sure that you are not getting any false temperature readings. We're able to switch temperature units from Fahrenheit to Celsius, as you can see, just by toggling this button. Then we're able to record data, all the data in here, whether it's minimum, max temperature, specific points, delta temperatures. So we are able to record all that data by clicking at that button. And what this button does is that we are recording a CSV file with each one of the data, and it's labeled per a column. So there's a column for delta temperature, a column for minimum temperature, and this is recorded with a timestamp. So right now you're going to see the CSV file that it was created through that feature. So we go to the folder, which is a thermal log folder. We open it and we will see the file that we just created in there. If we open the file, we're going to be able to see all the data recorded with its particular column. So this is a CSV file which the user will be able to open on Excel on their own computer, and it will be an easy task to create a trend graph or any kind of graph that he wants, or just to look to particular spots. The other option is to record a video of the thermal streaming. So right now, when we click on that button of recording, we're actually recording the whole thermal video, and then we have the ability to open a playback, and we included this slide bar so the user it's not required to watch a whole video just to see what happened, and he can kind of see a trend of events happening within the thermal image. This also records an actual video that you can actually access later within the storage folder. Now here we have a temperature difference, which is pretty much the ability to mark areas that will have a temperature either below or above the average temperature. So for example, here I'm going to go as low as 1 degree difference, and you see that we start marking areas that are below or above our current average temperature. We're able to fill those areas with a fill temperature difference area button, so the user has a better image of what's going on. Something that is important here is that these areas will be marked only if more than a certain amount of pixels are giving you below or above readings. So if it's a single pixel, the application won't mark it, because we try to avoid any false reading. So if you find more than one pixels within
Okay,
this image.
so this is an example of how this tool is able to mark areas of temperature difference within the heater surface. Just to give you an example, I'm going to be showing you difference in temperature on the heater while I place this paper between the camera and the heater surface. So if you notice here, I located in here, you might see it in there marked as a temperature difference. So this is just an example how a heater that has some particular problem with its temperature distribution will be shown on the application.
Okay, some of the other features on the application, its ability to hide all the min, max, and average and delta temperature readings on the live video. You're also able to save a particular frame that you're interested on. You can save PNG, and that will save you know, the particular frame that you wanted to see. This is particular interesting when you want to have, you know, a really clear image of um, a particular spot that um, it was interesting to the user. So here you can see the user is able to, you know, to play around, zoom in, zoom out on the image. Then, as I mentioned before, you're able to recalculate the heater contour. As soon as you click this, you'll make use of canny edge detection, contour detection, and morphology. So as I mentioned before, here you have thermostabilization points for particular temperature that you're interested on, and in particularly this is important for determining heater temperature stability. So here with these 4 points, what we're looking here at is that um, once at least one of these points reaches 448 degrees Fahrenheit, as you can see, the timer target temperature starts running, as well as the temperature stability timer. So the blue timer actually tells you when when one of the specific points actually reach the target temperature, and the purple one counts pretty much like how long have this um, for specific points being within a particular temperature that has been set prior by the user. For example, in this case, I set it to within 15-degree difference and within 15 degrees away from the target temperature. So what you notice that the blue timer actually was at 28 seconds, and then what it was reset to 0 seconds. That's because the temperature conditions were not met, so the timer started back to 0. But now it's reaching again the 30 seconds, and if it reaches the 30 seconds mark, that's we call it as a heater temperature status as a stable. So here, it's another really cool example of the application. It shows you the trends of, you know, how, for example, this heater, like where are the actual spots where all the heating starts, you know, and here you can see the trend um, within the thermal image that allows you to see, you know, where your heater's surface starts, you know, with the high temperatures, and how it becomes, you know, hotter as it goes with time, and how the surface temperature distribution looks, you know, from the beginning. Here we show the markers with the minimum and maximum temperature locations, as well as the specific points with all the recordings. So here we actually we were recording data which we're going to show you right now in this video. What you can do with this data, you can create these beautiful graphs from the CSV file information, and you can see the trends and how the delta impacts, you know, the behavior of the particular heater that you're trying to study. So thank you so much, and yeah, this was my project. Thanks.